Okay, so the very first thing that we want to do in this kind of problem is to be able to identify the kind of information that we have. So we know that we have the principal amount, which is $2,500. We have an interest rate of 7.75% or 0.0775. Okay, so let's say, after year one, what we will have is the $2,500 that we started with plus the $2,500 times the interest rate that we have, and the interest rate was 0.0775, which is 7.75%. Or what we see here is that if we wanted to be able to simplify this a little bit, we see that they both have $2,500 in common, these two terms. So if I take out $2,500, right, I am left with, if I factor it out, 1 plus 0.0775, which equals $2,500 times 1.0775. Okay, now we go back and let's look at year two. After year two, you will have now, what is the new principal for that year is $2,500 times whatever you get here. Notice that we're not really doing any calculations, we're just writing it down what it would be, but without actually performing the calculations. So 775. Now this is our principal for year two, but now we have to multiply this times the interest. So then the principal would be 2,500 times 1.0775 times the new principal. Times the interest rate, which is 0.775. Now if we look at this and we try to simplify, let's try to be able to factor this out. Now what we notice is that what they have in common is this, let me see, it's the term right here. This is what they have in common, so I'm going to take that out. So if I take out 2,500 times 1.0775, right, I am left with 1 plus 0.775, which is again 2,500 times 1.0775 times 1.0, I left a 0 there, 775, and this becomes 2,500 times 1.0775 squared. So what you notice this is we keep doing this for every single year. You will notice is that for the first year, right, that will be the equation. For the second year, we have 2,500 times 1.0775 squared. Now for the third year, if you start seeing the pattern, so after year three, we will have an equation that looks $2,500 times 1.0775 to the third, and so forth. So after 5 years, well, how would we calculate this? It would say $2,500 times 1.0775 to the fifth power. Once you put this in your calculator, I didn't work it out, but this is what it will, the amount of money that you will have after 5 years. Notice that for this, we could also use the compound interest formula, which is A equals P times 1 plus R over N. This is an R, this is an N, raised to the NT, where P is the principal, T is the terms in years, and N is the number of times that is compounded, right? So since it's, we say annually, then N equals to 1. Now you notice that we can apply the formula here and we'll get the exact same thing. So the principal is $2,500 times 1 plus the rate is 0.00775 raised to the well, let's say raised to the n, which is n times t, n is 1, t is 5 years, and we get 2,500 times 1.0775 raised to the 5 to the 5th power. So you could use either equation, so you could use the formula for compound interest, or if you remember basically what the concept of exponential functions are in exponential growth, then you could do it like this as well.